Okay, so we've looked at LSF and a little bit of similarity to do with lengths. It's time to look at area scale factor, or ASF. Let's do some calculations first. We've got two rectangles here. The first question says that we need to find the LSF, and that's straightforward enough to do. We just need to do the big side, which is 80, divided by the small side, which is 8, and we can get the LSF equals 10. We are multiplying by 10 to go in this direction. It says we need to then use this to find the length x, and so x is simply going to be 5 times 10, which is 50. So we can fill that in on the diagram. Now, we need to find the area of both rectangles. So the first rectangle, base times height, 5 times 8 is 40, and the second rectangle, 50 times 80 is 40. 4,000. Okay, so it's not done anything controversial so far, hopefully. D says, though, to work out the ASF, the area scale factor, what have we multiplied the areas by? So how do you get from 40 to 4,000? Well, you times, not by 10, but by 100. So our ASF, or we could have done that by doing 4,000 over 40, is 100. Our LSF was 10, our ASF is 100. So how are those two things related to each other? How is 100 related to 10? Come back to that question in a little bit. Let's have a look at another example. LSF for this question. So we're going from 5 to 25. So our LSF would be 25 over 5, which is 5. Lengths of x and y. So we need to times by 5 to go to the bigger triangle and divide by 5 to go to the smaller triangle. So x is 20 divided by 5, which is 4, and y is 3 times 5, which is 15. So we've got 4 here and a 15 here. Work out the area of both triangles. Okay, so the small triangle, half times base times height, so half times 3 times 4 is equal to 6. And the big triangle, half times 15 times 20. Notice we're not using the 5 or the 25, but that will give us 150. So what's our ASF? Do you already know what our ASF is if you know that the LSF is 5? How is 10 related to 100? So remember, we can always do this by doing the new area divided by the old area, and we get 25. So how is that related to 5? So let's look at what we found out so far. We had LSFs of, actually we had 10, and then we had 5, and the ASFs were 100, and then 25. What do you do to get from left to right there? You square them. 100 is 10 squared, 25 is 5 squared, and that's generally true. If we know the LSF, we can get the ASF by squaring it. That's what we're stating here. Area scale factor is what you multiply the area by to get the other area, and ASF is always, not just in those two cases, but it's always equal to LSF squared. That's the important fact for today, and that's what we're going to try and use. Because we're going to look at examples where we don't know all the side lengths. So we've got two rectangles here. It says they're similar, which means we've got an LSF of some sort. And it says the lengths in B are twice the lengths in A. So that's straight up telling you that LSF is equal to 2, because the lengths have been times by 2. It says the area here is 14 for shape A, and we want to find the area of shape B. So if the LSF is equal to 2, then the ASF, according to our little formula here, is equal to 2 squared. Our ASF is equal to 4. So that means the areas get multiplied by 4. So the area for B would be 14 times 4. So in other words, the area of B is 56 centimeters squared. Okay, let's look at another example. Mathematically similar, lengths in B are twice the lengths in A. So again, we're saying LSF equals 2. And because of that, we can say ASF is 2 squared, ASF is 4. The areas are being multiplied by 4. So to get from the small shape to the big shape, we times by 4. To go backwards, we divide by 4. The area of B is 40. Find the area of A. So we're going to need to do 40 divided by 4. The area of A is simply 10 centimeters squared. So you get the idea. If you find the LSF and you square it, that'll tell you what to do with the areas. Now that's true for surface area as well. So on this question, we've got a surface area of, let's not use red, it won't show up. Will yellow? Might do. Yeah, we've got an area of 19 for A, or a surface area for 19 for A, and we want to find the surface area of B. We're told here that the height of B is triple the height of A, so that tells us your LSF is equal to 3, and our ASF is equal to 3 squared, is equal to 9. So to get to the big shape, we need to times the area by 9. To get to the small shape, we need to divide by 9. So to get the surface area of B, we just need to do 19 times 9. That's 171 centimeters squared. So ASF works with area of a 2D shape, and it works with surface area of a 3D shape. Sometimes we do want to work backwards with this. So we've got two mathematically similar shapes. We're told their areas this time. We're told an area of 17 and 272. And we want to find the lengths that go with x and y. So if we talk about length, we have got 5, and we want to find what y is. We've got 17, this is for area, and 272. And this is the blank thing we don't know. So what we can calculate is we can actually calculate the ASF to start with. That's the big area divided by the little area, and that is 16. Now, what we want to do is use that area scale factor to find the length scale factor. We know we times the areas by 16, and we also know that LSF squared is ASF. Now, if we wanted to work backwards, if we wanted the LSF, we would square root the ASF. So our LSF is equal to the square root of 16 is equal to 4. And that means to get to the new lengths, we times by 4. So our corresponding length of y, 5 times 4, would be 20. Have a go at this one. Try and use the same principles. Unpause when you're ready in 3, 2, 1. So let's write down the information we have. Length of y is 40, areas are 19 and 304. So the first thing we should do is work out the area scale factor by dividing 309 by 19. That's 16 again. Remember, our LSF is equal to the square root of the ASF. So it's equal to the square root of 16, which is 4. And that tells us that so that was times 16. That tells us to get the lengths of y, we're going to times by 4. But we don't want the lengths of y, we want the lengths of x. We'd have to go backwards, we have to divide by 4. So our missing length is 10. 40 divided by 4. Cool. So let's increase that one more time. Let's look at VSF, or what happens to volumes. Example like what we did at the start. We want to find the LSF here. So what are we comparing? We're comparing 4 and 12. So 12 over 4 gives us a linear scale factor of 3. We want to use this to find the lengths of x and y. So if we're going to the big shape, we're going to times the length by 3. If we're going to the small shape, we're going to divide them by 3. So according to that, x is 5 times 3 is 15. And y is 9 divided by 3 is 3. Okay, so let's fill that in. We've got 15 and we've got 3. Now, what's the volume of each cuboid? So the one on the left, we would go 5 times 4 times 3. Remember, for a volume of a cuboid, it's just multiply everything together. For one on the right, we go 15 times 12 times 9. So our first one is 60, and our second one is 1620. Now it says we need to work out what the VSF is here. So what does VSF mean? Well, VSF means volume scale factor, and it's what would you multiply the volumes by to get from, how do you get from 60 to 1620? But we can find it, just like before, by dividing the two values by each other. If we do 1620 over 60 over 60, we're going to get our VSF is 27. Now, how does this relate to your answer to A? How does this relate to 3? How do you get from 3 to 27? Well, you don't square it, because that would give us 9. But if you times it by 3 again, i.e. if you cube it, you get the VSF. And this is our final sort of note, I suppose, that the volume scale factor is equal to the length scale factor cubed. I'm going to look at a couple examples of this, but that's basically the last note we need. So here we've got mathematically similar. The height is twice the height of A, so that's telling us the LSF is 2. And we know that the VSF is that cubed. The VSF is 8. So if we want to find the volume of B, we need to multiply the volume of A, which is 13, by 8. If we want to go backwards, we're going to need to divide by 8. 13 times 8, 104. Volume of B is 104. Okay, what about this one? Same sort of general deal. The height of B is twice the height of A. That tells us again LSF is 2. VSF is 2 cubed, so the VSF is 8. So to get to the big shape, we times by 8. To get to the small shape, we divide by 8, just in terms of the volumes. The volume of B is 120, divided by 8, gives you the volume of A, is equal to 15. That's it. Same as area scale factor questions, except we're cubing rather than squaring. So let's look at two last examples here. We've got volumes of 11 and 297. So we've got A and B. We want to find out the radius, and the radius is length. So we're going to need to use a linear scale factor to do it. What we have is the volume. So we have volume of 11 and 297 and a radius of 6. So what we need to work out is, what is the VSF? What are we multiplying by to get from 297 to 11? So we'll divide that through, and we'll get that the VSF is 27. Now the VSF is equal to the LSF cubed. So if we cube root the VSF, we should get the LSF. Cube root of 27 is 3. You can just type that in. And so that tells us that the lengths are times by 3. And so our missing length here is 18. Okay? One last example. Same deal. Have a go first. Unpause when you're ready. I'm going to go straight for it though. So information. We're told about height, which is a length. So height is 18. We're told about volume, which is 17 and 136 respectively. And we want to work out the VSF. What are we multiplying by to get from 17 to 136? Well, type it in. We're multiplying by 8. Now we know that that's equal to the length scale factor cubed. So the LSF would be the cube root of 8, which is just 2. So to get the lengths, we times by 2. Or to go backwards, we divide by 2. So our missing length is 9. Okay. There's a chunk of questions to have a go at, and homeworks to finish it all off. So make sure you've read through this. Make sure you're happy with everything that's been said. Make sure that you've got notes. And yeah, best of luck.